I think with the enter key or something. Good morning and welcome back to Engineering 101. I'm going to introduce a guest engineer in just a moment, but first I want to just remind you that you need to, if you haven't been doing short reports, you should be doing those. Also participating in the discussion board. If you have any questions about how things are working in this class, you're welcome to email me or Mrs. Flum about the course details, but I'm happy to answer your questions. I want to make sure that you're learning, and there's, it is a little bit of a strange course perhaps in the way it's structured, but hopefully it's mostly clear by now to you. But if you do have questions, then you're welcome to email me about them. And we're about halfway through the second module of the course. There's 4 modules. We're about halfway through the second module. You should be shooting for about 100 points every module. Plus the research paper, put that all together, and you should be able to earn an A for the course. So I've got my cell phone with me for if you have questions about the speaker's content and want me to pass those through to the speaker. I'll do that. So feel free to text me with those questions. And now I'm going to introduce our speaker, Mr. Joe Lewis. He is an electrical engineer from Mizzou, University of Missouri Columbia, 2008. I believe, and he has been with Sega as a controls engineer for 3 years. Sega is an awesome international company. Does design? Sega Inc. is a company that designs power plants as their primary role. So I'm going to turn it over to him. Thank you. Thanks. Sure.
Hi, my name's Joe Lewis, and I'll be talking about a few topics, mainly about how to decide if you want to be an engineer, the different types of engineering, how you transition into the real world, and my job specifically, and all that. So I'll get started with why you should choose engineering. The qualities engineers have mainly are if you like puzzles, you like to do puzzle solving, like Sudoku or Rubik's Cube or anything like that, that's a good sign that you should be an engineer. Curiosity, if you are interested in how the world works, why electricity, how it flows. I'm an electrical engineer, and how different equipment works and how a power plant runs, stuff like that. That's also a good sign that you'd be a good engineer. And organization is the majority of what I do. Just keeping things straight, keeping wires and cables, straight inside your head, keeping different schematics in order and how things operate that way. So I mainly just work on Excel spreadsheets all day, really, and just kind of keep everything organized. These are some good reasons to choose engineering. Engineers are always in demand. When the economy kind of tanked a couple years ago, there was a slight drop in demand for engineers, but still people were finding jobs. So you can always find a job as an engineer if you want to. You might not be able to go into this specific job market that you want to. For example, if you want to stay in Kansas City and there's a huge drop-off in jobs, you might have to move, but there's always going to be jobs somewhere in the country for engineers. And other majors are kind of ambiguous as to what exactly you're going to do with your job. If you get an engineering degree, you're going to be an engineer. And you know exactly what you're going to do, and there's a very defined career path for you. Whereas if you're, let's say, a business major, there's nothing wrong with that, but there's a lot of different types of business majors out there, and you could end up doing something you don't really want to do, or you don't really know where you're going when you graduate. So, engineering gives you a very clear idea of what you're going to be doing with your life. I attended Mizzou, which is, a good school. Really, any state school is going to give you the same leg up in engineering. I work with people who went to KU. I work with people who went to K-State and Iowa State. We're all good engineers. So really, it's your personal preference in terms of what kind of jobs you're going to get in the future. Mizzou's a good school, Rolla's a good school, KU, K-State. You're going to get a quality education wherever you go. But my biggest thing would say, piece of advice is a social life is very important in college. And so don't neglect that at all. I would say a social life is as important as, getting good grades in classes, because you're going to need to learn how to go into interviews and to, connect with people. Connecting with people is important no matter what your job is. As an engineer, I work with power plant operators all the time, and we have to be able to communicate with them and, convey what we want to say and read people like that. And in interviews, you need to be able to connect with the interviewer and get to know them. And, working with people is what you do, no matter what you do. So even as an engineer, having a social life is incredibly important. These are a few things I wish I had known when I went to college the first time. Finding a study group is incredibly important. And not just any study group, you need to find a study group that thinks like you do. When I first joined a study group, we were not on the same page. I would say something, and then they wouldn't understand what I was saying, and it just didn't work. What you should aim for is find people who you start to say a sentence, and then they immediately click and say, oh yeah, I know where you're going with this. So, if you're talking about circuits, and you start to do a math problem out and say, hey, this is where I'm going, they should be able to tell where you're going to go halfway through your equations, halfway through your explanation. The majority of the time, at least. Sometimes you have to go into more detail for everybody. But that's a good sign of somebody you click with, somebody you understand. And that's how you're going to get the best grades, is to work with people who think like you and can help you get going, get the ball rolling, If you just work with people who speak a different language than you, have a different thought process, you're not going to get anywhere. And it's going to be inefficient. It's all about efficiency.
Can you say a little bit more about how you use study groups in school and how many were in your group and how often you met, that sort of thing?
Yeah, I had a study group of 3 people, and we lived together, which is excellent. That's kind of what we want to do, is live with people who have the same major as you and who you can study with. And we would just, we would watch half an hour of TV shows, do an hour of homework, take a break, watch another half hour of TV shows, do another hour of homework. It was, very relaxed, and you just kind of spent an evening doing it and hanging out and studying that way. And that's really the best way to do it, in my opinion. If you're time crunched and you don't have that kind of time, you can always meet in the library and work that way. I would actually recommend meeting at a house, though, just so you can have a couch and you can spread out and be comfortable. I think being comfortable is probably the most important aspect of being in a study group. Also, don't panic. You're going to get some terrible grades sometimes. I took I could study all day for a test in, all week and feel really prepared for it. I come in and then I get a 40% of the test. That happens. It happens sometimes. And sometimes you're going to get a bad grade. Let's say you're used to getting A's and B's and you get a C in a class. That's going to happen. But don't panic. That's one aspect of what you're doing. And along with that is don't get discouraged. You're going to get a bad teacher sometimes. You're going to have a bad class that you don't understand. And that's not what engineering is all about. It's not about one class you don't like. Like I took Calculus 1, and I got a terrible grade in the first Calculus 1 because the teacher and I didn't click. But Calculus 2, 3, beyond, I got A's. And that's because I had a teacher that I liked, and we understood each other, and I got into the groove a little more, and everything started to kind of finally get rolling. So if you get one bad grade in the beginning, don't get discouraged. It happens, and as long as it doesn't become a habit, you can get over that. But if it does become a habit, then that's a problem. And it's like a class I didn't enjoy, I didn't understand was semiconductors, which I took, my junior year, and I was really frustrated with the class and didn't like it that much. But if you don't want to work in semiconductors as an engineer, you don't have to. So, get the class, understand the concepts, get how you're thinking, but don't think that one specific class is what you're going to be doing for the rest of your life, because it's not. But it's important to get good grades, to learn, to know how you think, but don't let one class get you down. It's not all just one thing. It's a plethora of classes and knowing how engineers think. That's really what you're going to be doing, is learning how to think as an engineer. And also do an internship. They pay really well. It's going to be paid better than any other job you can get during the summer, generally. And also, when you go into your interview, they're going to say, do you have any experience? And if you have an internship, that's experience. That counts as real world, real life experience. So I had a friend who did 3 years of an internship, and I didn't do one. I did a study instead. I looked into like nanotechnology and did like a study with a professor. And my friend did an internship, and he got way better offers than I did because he had real life experience that he could take. So I would say, do studies, but do that during the school year. Do studies with professors at that time. If you can do a co-op, which is during the school year, but you get credit and also do like an internship type thing. Or if you can do an internship, absolutely do that, because you're going to get experience and you're going to get paid really well. So can't emphasize that enough. One thing I really regret is not getting an internship. College, as I said earlier, mainly tests ability. It tests your aptitude to become an engineer. So while you're going to use specific knowledge that you learn, not any specific job isn't going to use the majority of what you learn. It's mainly testing your ability and stuff like that. Like I work as a controls engineer, and I use a few classes that I took, but I don't use, for example, semiconductors. But it's important to have all those classes so you have the option later in life. If you say, I want to become a power engineer, or I want to become a circuit design engineer, or I want to become a controls engineer, it's important to have all those classes in your background so that way you have the option. But any specific job isn't going to use everything you know, but it is going to test your ability to learn and function and stuff like that. So, you should be getting relatively good grades and understanding the concepts, because knowing how to learn, knowing how to think as an engineer is what your classes do. Different types of engineering. This is what you can go into. I worked for the first 2 years, and I'm currently doing a project right now as an electrical engineer, which is stuff like wiring lights in a building, getting electricity to different equipment, and stuff like that. So what I do is count the number of cables you need to get to equipment for a power plant to work. Like let's say we want a motor to start up, or whenever you say to start, we have to get wires to it for a control switch, wires to it for a PLC, which is like a controller that a power plant operator can use to automatically control things. We need wires for it for if pressure drops in a power plant so that the equipment will automatically turn on. We have to get wires to a motor for all of that. So, drawing up circuits and interconnecting and everything like that, that's pretty much what an electrical engineer does. And you're going to be counting cables and making sure you have the proper number of cables. It's a whole lot of organization. That job is mainly Excel spreadsheets and knowing where everything is and keeping everything straight in your mind. So it's a whole lot of that, and also schematics and knowing what kind of wires to use and stuff like that.
Can I interrupt, Joe?
Yeah.
You're talking about how an electrical engineer who does, say, wiring of motors in and around a power plant is mostly spreadsheets. But I think most engineers would think of the mathematics behind all that as pretty complicated, the three-phase power and the details associated with all that. Would you say that's a special kind of engineer that can figure that kind of stuff out, that's maybe better at math on average than the average engineer? Or do you think any engineer could probably work into that role?
All engineers should have that concept. They should understand three-phase power and all how it works. The majority of what you do in a power plant is the motors and the valves and getting wires to that. And then there's the generator, which, if you think about a power plant has something like, 50 motors, and it has one generator. And that one generator takes up most of your brain power, most of your effort, because it has the most complicated stuff to it, and you have to have the right cables going to it for the three-phase power. You have to have everything correct in that part. And you can specialize in that, or you can, kind of ignore that. But that's where that one aspect is probably the most difficult part of doing power plant engineering. But in terms of the number of valves, number of motors, number of that kind of stuff, there's way more of that. So you're going to be working with those specific things more often than not. But you will be doing some mathematics when it's called for. And it's important to get that right when you get to that, because that's where the power plants make all their money. It's important. So it's important to get, to understand all those concepts and be able to do it. But the majority of your time is going to be spent on things that aren't quite as complicated. Okay. As a controls engineer, which is what my current job title is, you pretty much build Ruth Goldberg machines all the time. If you've ever played the game The Incredible Machine, I don't know if anybody's ever played that. That's pretty much what being a controls engineer is. You just kind of, let's say you want a valve to open to a certain amount. And then you say, okay, I want you to open up to 70%. And then the valve motor will ramp it up to 70%, overshoot by a little bit, get to 72%. And then the controller will say, no, we want you to get to 70%. So it'll do a little wave until it gets right to 70%. And so that's what I do, is I make sure that different controllers get valves and motor speeds and everything right to where they need to be in order to run a power plant. Like one good example is if you want combined control for a power plant, you say, I want 100 megawatts in my power plant. Well, you're going to have to open up valves that let steam into the turbine, so it turns the turbine to a certain speed to generate all that power. You're going to need your coal mills to feed coal to heat up the boiler to a certain amount. So you need to feed coal at a certain speed, and then you need a boiler to be filled with water so you can make steam. So you have to control all those three aspects at once in order to get your exact megawatt reading that you want. So the controller would, ramp up the turbine valves to let in more steam, throw in more coal to burn up more water, to boil more water. And then your boiler feed pumps, your pumps that shoot in water, would fill up the boiler more so you have plenty of steam. So it has to control all three of those processes at once. So,
I have a question from a distance student. What other engineers do you commonly work for? Or with, I guess?
We work lots of mechanical engineers and civil engineers. Mechanical engineers we work with all the time because they're the ones who actually design the real valves. And as a controls engineer, we're not actually concerned with the real physical valve. We're concerned with how you control it. So a mechanical engineer will put in the valve and the pump onto it and then do all the piping. And they'll calculate all of the pressure drops and all that kind of stuff. And we will control it. We'll be the brains. So essentially, controls engineering is the brains, and mechanical engineers are all like the heart and the pumps and the veins and all that stuff. So we control everything, but we need mechanical engineers to make all that. For civil engineers, if we want to put in a bunch of switchgear, which is how the big giant breakers that you can put in a bunch of power for, so you can feed all your motors. Well, those things are heavy, and we need structure to hold all that up. So we work with a lot of civil engineers for that kind of stuff. And environmental engineers we work with a lot because right now a big thing in power plants is NOx emissions and carbon dioxide emissions, and limiting all that. And there's lots of regulations on that. So we need to work with chemical engineers and environmental engineers to find out how much, how much NOx you can take out of a power plant stream and everything like that, and figure out, how much we should pump in and stuff like that. So we work with a lot of chemical engineers on that. Other types of engineering. Power engineers, my company does that too. I haven't really worked with them all that much, but you're pretty much putting up power lines and substations and determining what size of cables you need to run and what fault currents are, which is where current comes out of a line and reduces efficiency, and you need to figure out all that kind of stuff. I haven't really worked with that a whole lot, so I can't really speak much on that. But I have friends who work in there, and they say power engineering is very electrical oriented. Whereas, like as a controls engineer, I work with the mechanical engineers are the guys. They set up everything because that's set in stone, and then we work with the software. And since we can change the software quickly, we're the people who are kind of supporting the mechanical engineers. Whereas in power, it's all about the power engineers and the electrical. So, circuit engineering is the next thing. I don't know if that's actually the proper name for it or not, but that's stuff like working at Garmin. If you're going to build GPSs, or if you work at Apple and you build, actually Apple doesn't design the hardware themselves, but if you work at companies that design hardware and stuff like that, you're going to be doing a lot of circuit theory, a lot of MOSFETs, which is switches where it lets power in and out, depending if you say let power in, capacitors, taking them in and out to increase or decrease the cost of a unit, stuff like that. So it's a whole lot of, working with traditional electrical engineering that you learn in school. You're going to be learning most of that kind of stuff like semiconductors and circuit theory and circuit design classes. It's all going to focus on that kind of stuff. You'll also be doing programming microcontrollers, a lot in that. So if you want to get into some programming aspects, programming microcontrollers is a big thing for circuits. And then there's other, which simulation engineering, which is what I did for a year or two. And it's just designing a power plant inside of a computer so that way power plant operators can learn about how the power plant actually runs and stuff like that. And you can test control systems and stuff like that. So simulation engineering is one thing. In graduate school, if you want to do research, if you are interested in nanotechnology, or if you're interested in developing new stuff, like new semiconductors, new materials and stuff like that, graduate school is a great thing to go into. I wouldn't recommend graduate school if you're going to get into what I do, because it's not really that beneficial for what I do. But if you want to get into research or higher end electrical engineering jobs, then that's the course you want to go through.
Another question from the distance students. Would you change your profession if you had a second chance? Why or why not?
Well, I did kind of have a second chance, and I'm still an electrical engineer, but I started off as a electrical engineer, which is the running the wire throughout the power plants and stuff like that. I changed it to a controls engineer because I didn't understand the difference when I first graduated. So I changed then. So, I mean, in my other slide, I say complacency is bad. You don't want to get complacent in your job. You want to like what you're doing, and you can change within the engineering field to different types of engineering if you want to. It's not a big deal. I did it, and I'm doing fine. If I wanted to get into something other than engineering, I don't know, probably not. I like engineering quite a bit. It gives me a lot of freedom in my life. I mean, you make a good salary, and you get a lot of respect, and you have a lot of opportunity to do things. And engineering companies are typically really good companies in terms of letting you work on an island. If you want to have say over exactly what you do and work by yourself and not have somebody breathing down your neck all the time to follow this code and do all this, and you can kind of work with your own creativity into it. Like, I want to find this solution, so I'm going to work using the knowledge I have to find a solution. You get to do that with engineering. So you get you get to be a little creative in your job, and so I really like that. So I don't think I would really choose anything else, just because everything else seems kind of more hard line and less thinking involved. It's less creative and less using your own ingenuity to solve problems. So, what interviewers look for when you get a job that's going to be important, and this is where having a social life in college really helps, is interviewers. You think about this. Your boss who's interviewing you is saying, I'm going to hang out with this person 8 hours a day, every day. So you need to be personable. You need to be excited. People will hire people who they get along with and who like their job more than people who are technically qualified. So if you're not excited about your job, looking down all the time, not really wanting to work there, and just kind of doing the motions, you're not going to get the job. It's they have to hang out with you 8 hours a day, every single day. So you really need to focus on being personable and get along with people. I mean, get along with people is huge. I talked about complacency earlier. You can change. It's no problem. If you don't like your current job, you can move around as an engineer. You have lots of options out there, and you have lots of different types of engineering you can go into. If you don't like what you're doing right then, look for something better. I mean, I was lucky enough to find a company I really like right off the bat. But I know other people who didn't like their companies originally, and they had to switch. But, you don't want to get complacent, because you're going to hate yourself. So look around, and then don't panic once again. You're going to screw up at some point in time in your real life job, and it's going to be, it's going to look expensive. It's going to look like you're going to waste a lot of money for your company, but everybody makes mistakes. So don't sweat the small stuff, and just try to keep your nose to the grindstone and do what you can. And then be organized, like I said. That's absolutely huge. I didn't learn that until probably this last year, and then that created a lot of problems for me. So keeping everything in straight, keeping all your schematics in line, and knowing exactly where they are, and knowing all the equipment, it's huge. I can't emphasize that enough. My job specifically, as a controls engineer, I worked for 2 years, or a year and a half, as a simulation engineer. So I did a lot of that, which is, upgrading. If they upgrade a new control system, they usually make a simulator to go along with that. So I did a lot of that. Power plant retrofits, which is just installing new software or new equipment, upgrading power plants. Is a lot of what my company does. That's mostly what my company does. And just a few examples of what a controls engineer will do. You tune a boiler. Like, let's say you go out to a power plant and the operators say, hey, this isn't responding quick enough for us. We say we want to drop the pressure and the control system doesn't do it fast enough. So you'll go into the software of the computer, of the power plant, and you'll say, okay, you have like some numbers that will change how the power plant works and feels. And then you just kind of play around with those numbers until the power plant says that's what we want. And it's a lot of experience and just feeling things out. There's some calculations that go into that, but once you get into your field long enough, like I know a guy who's been in the field for 30 years, and he can just go out to a power plant and feel out a boiler and tune it exactly how it needs to be without doing any calculations, just because he knows. And he can watch how the boiler reacts and do all that. So that's a lot of what you're going to be doing. Upgrading software. A huge part of being a controls engineer is just knowing how software works. I mean, this is kind of an example that's going to dumb it down a little bit, but let's say you're upgrading to the new Windows Word, Microsoft Word that came out recently. Well, that was a big change, and you didn't know where all the same buttons were and everything like that. So when you upgrade software, you need to know where all the new buttons are. So just knowing how different control software works and how to navigate it, that's a lot of what I do.
Except your buttons control a multi-million-dollar machine.
Yeah, exactly. And if they screw up, I mean, a trip at a power plant going offline, not only does it cost a ton of money to bring it back up, but you're losing all the money that you would sell that power for. All that opportunity cost is being lost. So preventing trips is huge, and having so if a power plant operator doesn't know how to react because something moved, then it could be big money. So we upgrade control software. Let's say you want to go to version 5.0 to version 7.0 because 5.0 is ancient and no one uses it anymore. You have to go and reprogram everything. And so that's what I do a lot, is taking a look at their old control software and then reprogramming it and making it work with the new software.
How did you get? Oh, go ahead.
How much more hardware would actually go into retrofitting a system like that
Okay.
with that new programming overhead?
Okay.
Repeat the question.
You asked how much hardware goes into upgrading software as well. And it depends on exactly what the company wants to do. You're going to need to install, in most cases, new controllers, which is computers that house all the software. So you usually need to upgrade controllers when you do that. So it's all new computers, essentially, because power plants do upgrades every 20 years, every 10 years maybe. So their computers that they're using in their old control system they're not going to handle the new software. So you have to install all new stuff like that. In some cases, you need to install new fans because with the new software, you can be more efficient, but to get that efficiency, you have to install bigger fans to work with the power plant, or a new mill to handle the amount of coal that your control system can handle now. But a pretty common thing is it's called ID fans, induced draft fans, FD fans, forced draft fans. We have to install a new one of those quite often, so it can handle all the new load and all that kind of stuff. So usually you don't upgrade the whole power plant, hardware-wise, but you have to upgrade the computers at least, and then in some cases, one or two pieces of equipment to maximize efficiency. One other thing is fans with variable speed drives. That's something that you install new now too, because fans can run at different speeds to maximize efficiency, and so you have to install new fans if you're going to install that kind of a control system. So you see that a lot too, is upgrading one or two pieces of equipment with a control system. Control application is kind of what I described earlier, where if you want to say I want 100 megawatts and it has to control all these different aspects, that's kind of what control application is. And making sure all your right burners come on, and making sure, just a good example of if you look at a boiler and how that works. The boiler has heat under it, boils up the water goes, it becomes steam and goes to the turbine. And then you need to put water in there to keep the boiler above a certain level. So you have to measure how much steam comes out, and then you have to match how much water comes in, so that those two things are even, so the boiler doesn't drop below. So, control application is turning on the pump and opening up a valve enough so that it lets in the correct amount of water. So you do that all the time. You do a lot of, matching two numbers and then moving a valve around to make sure that those two numbers match. You do that quite a bit. I missed one thing back there. My current project that I'm on is more of a connect the dots than anything else. I take, if you have a piece of equipment, like a motor, that needs to automatically shut off if pressure in one area drops down or becomes too high. Well, I have to connect a wire from that motor down to the to the pressure sensor, and then back there. So a lot of what I'm doing is just connecting the dots with wires. So I'm saying, okay, it goes from the power source to the motor, through the control switch, to the pressure system, back to the motor, and then back to the control system, and then back to the power source. So it's a lot of playing connect the dots and making sure that your wires all match and that you have everything interconnected like you need to. It's called hardwire interlocks. Hardwire interlocks. And I do that a lot. So yeah, that's pretty much everything I have planned. So if you guys want to ask any questions about.
With your job and all this you do you ever have time like to go with your family for like Christmas or holidays or anything, or does that affect you at all?
My specific job, I have tons of free time. I mean, I work 40 hours a week, and that's pretty much what I work. There are times when if you're doing a power plant outage, you're going to be spending 60 to 80 hours a week when that happens. But they don't do that during Christmas because no one wants to do that. So like the organizer of the power plant who's scheduling the outage, they're not going to schedule it during Christmas because they want to be home with their families. And so I want to be home with my family then too. It's not a problem. There will be times when you have to go out to the field. So I'll have to drive out to middle of nowhere, Illinois, for a couple weeks to install something. That doesn't happen all the time, but when it does, yeah, it hits home. But I normally, 80% of the time, I'm working 40 hours a week, and so I have plenty of free time. And engineering gives you, it's a real career, it's a real job. You're going to get some good vacation time. I mean, you get competitive salaries, you get competitive vacation time, competitive health benefits. I mean, that's a good reason to go into engineering. It's just because you're going to have a lot of benefits like that other jobs, other fields can't compete with. So.
How often do you travel with your job?
Question was, how often do I travel with my job? I probably travel 1 month out of the year, I would say. And there's for different reasons. Sometimes if you're going to go do a power plant upgrade, you have to be there. Sometimes I go to a conference and you have to travel for that. Usually it's boring places because they put power plants in boring places. But, like I went to a simulator conference in San Diego, which is kind of fun. It really depends on exactly what field you get into. And that's counting when I need a hotel room. Other travel, I go to Topeka all the time. I probably go there for a day or two every month, every couple weeks. So that's a lot of day traveling. I just travel there for the day and come back. Because power plants like to hire local people in the region. Because it's expensive to fly you out. They pay for your travel usually. So they like to hire local engineers because it's cheaper to get you to drive there. So you're going to do a whole lot of local Midwest kind of stuff. So, yeah.
You also look into transformers?
Question was, do I look into transformers? That's more, well, I can do some of that. I would say it's more power engineering, which I haven't done personally. But that's a whole lot of ramping up your voltage and bringing it down, and you could be seeing a lot of that for transmission engineering to get it to homes and stuff like that. I do a little bit of that because some equipment in the power plant takes 480 volts, some takes 4,160 volts. So I have to go up and down for that, but you'll see that more in commercial power engineering. So.
So, saying that, I know when you're trying to connect the power from the generator outside,
Mhm.
go through like delta star, you all need to
Yeah, the question is, how do I connect the generator to the outside world, and how do we deal with the different types of three-phase power for that. I haven't done a whole lot of that myself, but I have wired up the breakers that connect it to the outside world. And like one thing I can tell you for doing that is the power plant, when you first start up a power plant, it's not generating any power. So you have to connect it to the grid to bring in power for itself. And then you get the power plant up and rolling up and it's generating power. And then you have to swap over the breakers. So that way you're generating power for your own power plant and putting it out to the grid. So you have to sync that. You have to make sure that your power plant, your generator is running at the same frequency as the real world, as the field. And so you have to bring up your power plant, and then your frequency is going to go up and down until you're right there, and then you sync it in, you switch over the breakers, and then you connect it in there. So there's a whole system for doing that, and it's called the exciter, is what we use for that. And you have to match voltage and speed, and then sync into the world. So
So use external power to set the generator?
the question is, do we use external power to excite the generator? We have something called the exciter, which is what matches everything inside of the inside the generator. I forgot how that's powered exactly, but initially everything is powered through the world. Everything is powered through the grid because you're not generating anything from a cold start. I don't know exactly how the exciter is powered. It might be a battery. I'm not sure. I'd have to look into that. I don't really work with that aspect all that much personally, but yeah, initially you're getting all of your power from the grid. Yeah.
About how many percentage-wise of the employees at Sega are engineers versus, say, supporting technical people like draftspersons or other technical people?
I would say that my company has probably, I'm going to guess 60 to 70% engineers, because support staff is important and it takes up a large number of all of our services are engineering services. We don't provide anything that's not engineering. But you need to have an army of people behind those engineers to make sure everything gets done. I'll give you an example of how I'm working right now. Let's say that we need something drawn up, like you're making a new soot blower for your power plant, which is just a motor that blows soot. I'll draw it up by hand, and I'll draw up the wiring diagram by hand. Then I give that to drafting, and then drafting puts it in AutoCAD. And then they make it look exactly how we want it. They give it back to me. I review it, make red marks on it, and then send it back. And after about 5 iterations of that, because the client asks for different hardwire interlocks and all this other stuff, we eventually get what we like. So there's a whole lot of communication with AutoCAD there. And if we want to put out a new contract or a new scope of work, we have to work with TDS, Technical Document Services. And they put everything into the right format so everybody can see, and we have our comments and everything like that. Then we have a marketing staff, and we have HR, human resources, and accounting. So all those people are involved in what we do so that we can focus on just engineering.
Regarding other support, do engineers mostly do the project management and the budget issues, or is that something that like business majors might come in and do, or how does that work?
I can't speak for all the companies out there, but in my company, we engineers do that. So we promote from within. If you're an engineer and you show an aptitude for budget and working with people and being able to a big thing about being a manager as an engineer is having a backbone, being able to tell the client, no, this isn't in our scope, or yes, this is in our scope and we'll do this, or working with people to match expectations. So, being a strong-willed person is a big part of that. We promote within, not all engineers are cut out to be managers, but a lot are. So within your company you find the managers that you need in general. So.
For your specific job, you do a lot of programming-like work, I would imagine, but you probably didn't get trained in that software as an undergraduate student at Mizzou.
Yeah.
So if an electrical engineering student wanted to maybe think about controls as a future, what sort of software should they be learning, and what could they do outside of school to better prepare?
That's a really good question, because I was not prepared when I first went into engineering for the software that we used to design control systems. I would say take a PLC class if you can, which is programmable logic controller. That's going to be very similar to what you'll see. And then, AND gates and OR gates. I don't know if you guys know about that yet, but knowing logic and how that works is going to give you a leg up. And other than that, just if you're good with computers, if you can take a new program, like let's say you've never seen PowerPoint before, and you pick up PowerPoint and you can get it, just having that ability is going to be important, because that way you can pick up any piece of software and intuitively know how it works. I mean, I played a lot of video games as a kid, and I kind of say that was a good thing for me, because now I could pick up a GameCube controller and know how to play Mario Kart within 5 seconds. And the same thing as you're doing with control software. It's because you're just going to have to pick it up and then intuitively know what happens, and you get that by just playing with software. So.
About C++ programming or something like that, is that worth their time?
Not for what I do specifically, but for other engineering work, it does. I have a friend of mine who works as a circuit engineer, and he does C++ all the time for designing microcontrollers and putting in test software and all that stuff. I don't personally, but lots of people do. So.
Okay.
Yep.
Sorry, I'm jumping all over the place here with
That's
my
fine.
questions. With internships, does Sega hire interns? If so, how do you get on board with Sega? Or how would that typically work? Is it word of mouth? Is it interviews?
We have in the past. I don't know if we currently are or if we plan on it again, but we have hired interns in the past. Usually, that's word of mouth for at least a company of my size. But for bigger companies like, larger consulting firms, job fairs at college, they always have job fairs, and you can walk around from booth to booth and apply for an internship and get in. And that happens all the time. So that's how I found my work, is through a job fair. So.
Going back to your school days, how many hours a week do you think you studied? You said you had to balance your social life with your study. When finals week was approaching, how many hours a week versus the regular semester?
I'll be completely honest, and I'll say that I probably spent, in any given week, I would spend about 2 days studying for about 5 hours a day, maybe 3 days. So 10 to 15 hours studying outside of it. But on finals week or before a big test, I would study Sunday, and I would just cram the entire day. So I would spend like 16 hours studying before a big test. It's probably not the best way to do it. Probably the best way is to spread everything out and to learn that way. But it worked out for me. And it depends on, by this point, everybody should know what kind of a studier you are and how quickly you catch on things. I had a friend of mine who would study 5 hours just before the test, and he'd ace every single one of them. I would study for 15 hours, and I would be fine. I had another friend who'd study for 30 hours, and he'd get a worse grade. I mean, it just depends on having the right study group, being efficient with your time, and all that stuff. And if you're a good studier and you can pick up on things quickly, use that. But I would say that I probably spend about 15 hours a week.
Okay, well, I think we've used up our time, so
Okay.
let's thank our speaker.
Great, thanks.
Thank you.
Thanks.
And that's it for this week. See you next week. Thank you.